So the next part which you are going to see is about one particular type of a measuring instrument. So this instrument measures the changes in temperatures with respect to change in resistance. Yes. So this device is called as Resistance Temperature Detector. So this particular measuring instrument is used in industries for measuring temperatures up to 800 degrees Celsius. So now we will see about the construction and the working of this particular instrument. So what is an RTD? So it measures the temperature with respect to change in resistance. So if the temperature changes, the resistance value of the RTD is going to change. So there are two different terms which define this change in resistance. So one is called as a positive temperature coefficient. So in positive temperature coefficient, if the temperature value increases, the resistance will increase. Whereas in negative temperature coefficient, if the temperature increases, your resistance value will decrease. So this RTD is a positive temperature coefficient. So as the temperature increases, the resistance value will increase. So what is the basic terminology or the concept used here? It is just a measurement wire. A wire chosen material which changes its resistance value based on temperature. So you have a different material types for wires, like copper, nickel. No, in this case we are going to select platinum. So now you may wonder why platinum, which is a very costly material. So the reason we are going to choose platinum is this platinum provides a very linear relationship between temperature as well as resistance. So the as the temperature changes, the resistance will change very linearly, and it is not very easily reactive with the atmosphere or other any external conditions. So this is the reason why we choose platinum as the sensing material for RTD. So it can measure temperature ranges from around minus 200 degree to 650 and up to some cases 800 degrees Celsius. So next we will see about the construction of RTD. So based on the construction, you can classify the RTD into two different types. So wire wound RTD as well as thin film RTD. So in case of a wire wound RTD, you have a ceramic substance, and over the ceramic substance you have the platinum wire which is wound. So in case of a thin film RTD, you have a flat surface which is usually a insulator, again if it can be a ceramic, and over that there are traces of platinum which is embedded into it. So this wire wound RTD can be used for more rugged applications. Since its construction is somewhat rigid, you can use that for more rugged applications, whereas a thin film RTD can be used for less fragile applications. So in both the cases, the working concept is going to be same. So since we are choosing the material as platinum, we can manually calculate the what is the actual temperature if we measure just the resistance value. So the formula for calculating that is RT, which is the resistance at that particular temperature, is equal to R naught, which is resistance at 0 degree. So in this case for platinum, the resistance at 0 degree is 100 ohm. So RT is equal to R naught into 1 plus alpha T. So alpha is the coefficient for Pt100. So the value is 0.00385. And if you just use these values here, you can actually calculate the temperature. So this particular condition assumes that you have exactly the same length of lead wire as well as the same material of used in the lead wire. So only in that particular case, this 3-wire RTD will work out. If you are adding extra length for one lead wire and the second lead wire is having a shorter length, then this formula is not going to work out, right? So as you can see this diagram, you can clearly see that the resistance, two resistance at the top and bottom, they are cancelling out, and you get the exact readings for the resistance of the RTD. To conclude or summarize the RTD, it is a very stable instrument and which provides an accurate reading of temperature, whereas it has small issue with a lead wire resistance. So this lead wire resistance, as we discussed, creates a error in the reading. So how do we eliminate that? By using a 3-wire RTD. So with the proper design, proper installation and proper calibration, this RTD will ensure that it returns the accurate value of temperature in industries. Thank you.